All right. And if Shayna is able to make it in, more power to her. I'll just kind of keep a little bit of an eye on the number down there and see if that'll let me know if anybody new makes it in. But all right. So the goal for this week is 4.3 and 4.4. 4.3 is where we're going to start today. Oops. This is logarithmic functions. Okay, so what is that? A logarithmic function with base A is denoted by log base A and defined as, so if A to the Y is equal to X, then log base A is equal to Y. Log base A of X is equal to Y. So a log is the inverse of an exponential function. Okay. We use the definition of a log to switch. In and out of log form and exponential form. So in our log format, we have log base A of X is some value Y. Notice A would be our base and Y is our exponent. In exponential form, that means that A to the Y is of some value X. Notice the base and the exponent are the same. Their placement is different. It's a rearrangement. But we're just switching format. For example, log base 10 of 100 is equal to 2. That's what it looks like in log format. In exponential format, this would be 10 to the second is equal to 100. Log base 2 of 64 is equal to 6. This is the same as saying that 2 to the 6th power is equal to 64. Log base 16 of 4 is the same as saying 16 to the 1/2 power is equal to 4. Keeping in mind that the 1/2 power is just one way of writing square root. Okay? Keep in mind, as inverses, f inverse of f of x has to equal x. So the log base a of a to the x has to equal x. And if I take the f of x, or the inverse, wait, if I take the function of the inverse, yeah, then I would have a to the log base a of x. This also has to equal x. In this case, x can be any real number, but in this case, our x has to be greater than 0. Because our log's got to be positive numbers. You can't take the log of a negative number. You can only take log of the positives. Okay. So far, so good. Is this somewhat familiar to you from intermediate? Yeah, okay. All right, Garrett. All right, some basic properties. There are 4 basic properties that the expectation is they come directly from exponential form. The first one is log base a of 1 is always going to be 0. So no matter what your value of a is, the log base a of 1 always has to be 0. And this comes from the idea that a to the 0 power always has to equal 1. So this is the rule in exponential form, but in logarithmic form, that would look like log base a of 1 has to be 0. The second basic property is that log base a of a is 1. Again, if a is the base and 1 is the power, this comes from the exponential rule that a to the first power is the same as a. The third rule comes from the inverses. If a is our base and x is our power, then it must be true that that is the same as a to the x. I almost think of it like an identity rule. If it's a base to the power, it has to equal that base to the power. A to the x has to equal a to the x. The fourth also comes from the inverse. If I have a raised to the log base a of x, that has to be x. This comes from the idea that log base a of x has to equal the exponent log base a of x. Again, as an identity. Questions? Okay. There are two types of logs specifically that can be done on the calculator. The rest cannot. The first is known as the common log. The log with base 10 is the common logarithm. And is written without the 10. So if you see log base x, I'm sorry, if you just see log of x and there's no base, this is intended as log base 10 of x. The other one is the natural log. The log with base e from last week, 2.718. Is called the natural log and is denoted with ln. I have a tendency to put it in cursive, although lots of people don't. So if you see ln x, or sometimes ln x, this is the same as log base e of x. Both the common log and the natural log are on your calculator. They are the only two that are. Calculator. On your calculator, this button looks like log, and this one looks like ln. You can see on my calculator, they are in the first row. I'm sorry, the first column. There's my log base 10, and there's my natural log. Okay, let's try a few. We're going to let y equal log base 6 of 36. And we want to find the value of y. So, first question. If your base is 6, can you use your calculator? You cannot. The calculator can only be used for a natural log or a log base 10. So we cannot use our calculator for this problem. I mean, okay, later this week I'll show you how we can switch that up. But right now we cannot. Now, you might be able to, Garrett, yes, if you know your change of base formula, but we haven't done that yet, so this is not a change of base. All right, so what are we going to do? Well, we can do this one of two ways. We can use our definition. By definition, we know that the base to the power has to equal 36. So I could say 6 to the y has to equal 36. Looking at this problem, can you rewrite 36 as a base 6? 36 would be the same as 6 to the... Yep. What does that tell me about my y value? Yep, y is equal to 2. So some of these we can get by simply switching up the format. I like to use my properties a lot. I like to use properties 3 and 4. So I would take something like y is equal to log base 6 of 36. And I just essentially put them as the exponents with a base of 6. So I'm raising 6 to the y power, and that has to equal 6 to the log base 6 of 36. This gives me 6 to the y power is 36. And I get the same thing with y equaling 2. Both of these ideas work. Neither of these is an incorrect method. Sometimes it's just a matter of what you see or what you can identify first. Let's see. Here I have y is equal to e to the ln square root 3. This one is a matter of remembering that this is e to the log base e square root of 3. Ln is just log base e. Now that the base is the same, base here, this is just square root 3. Log base x of 8 is 3/2. This is my base, that's my exponent. X to the 3/2 power is equal to 8. Well, what do we do to get this? I'm going to square them both. Because if I square it, then I have x cubed is equal to 8 times 8, or 64. And then I can take the cube root of both sides. Questions? Okay, there will be some that you can do on your calculator. As well. It's a matter of recalling that log of 50 is log base 10. On your calculator, that's the second one, and all you need to do is log 50. We're going to get about a 1.699. On that, if you have an ln or a natural log, ln square root 2 and I get a 1.68. So there's some practice with the calculator on here. There's some practice with the logarithmic properties. I should mention that they go through the 4 properties for the natural log, which are the same as the ones for the regular log, as if they're new ones. They're not. They're not. So those are all kind of similar there. Nothing too earth-shattering, I hope. But yeah. Okay, where are my time was? Great. Okay, let's try this then. Ooh. Okay, doggos. I don't know if you can hear them. We got doggos going nuts by my house. Okay. Oh. He does not like. Okay, good. All right, all is well outside. Okay, so logarithmic functions, if we're going to graph them. All right. Yep. All right. Here we go. So we're going to let f of x equal 4 to the x. And we want to graph it. We did this last week. This is part of what we did. And if you recall, we talked about how you can get this graph quickly using 3 points. If we let x equal a -1, then we'd have 4 to the -1, or 1/4. If we let x equal 0, then we would have 4 to the 0, which is 1. And if we let x equal 1, we'd have 4 to the first power, which is just a 4. That this would give us 3 points rather quickly: -1, 1/4, 0, 1, and 1/4. And these points could be used to quickly graph f of x. Oops. All right. Then f inverse of x would be log base 4 of x. And the graph of the inverse function is a reflection of f of x over y equals x. So if I were to graph y equal x, we've talked about all of this. We're just trying to put it all together here. So there's y equals x. Do you remember what happens to the points when you reflect them over y equals x? What happens to negative 1 1/4? Correct. When you reflect it over y equals x, or when you graph the inverse function, the x and y values swap or switch positions. So instead of the point negative 1 1/4, we're going to have the point 1/4 negative 1. And instead of the point 0 1, we're going to have the point 1 0. And 1 4 will become 4 1. So the graph of the logarithmic function, 1/4 negative 1, 0 1, or 1 0, sorry, is a reflection in y equals x of the original. Couple of notes. We have a vertical asymptote instead of a horizontal. So at x equals 0, we get a vertical asymptote. This aligns with the fact that our x values have to be greater than 0 in a logarithmic function. Okay? Note that as x moves to 0 from the right, y goes to negative infinity. And as x goes to infinity, y also goes to infinity. These are the end behaviors of our base function. Good? Questions? Okay. All right. So, what are you going to be expected to do? You are going to be expected to graph using transformations. All right, so here's our first graph. Log base 5 of x minus 4 is equal to y. Okay, I'm going to start with the exponential function. You may not always have to do this, but I'm going to start with the exponential f of x is equal to 5 to the x. This will give me the same 3 points that we talked about last week. So if I let my x equal a negative 1, then I have 1/5. If I let my x equal 0, I have a 1. And if I let my x be 1, I have a 5. There, there. 5. I'm starting here. Because then log base 5 of x, which is my base function, will use the points. All of these reversed. 1/5, -1, 1, 0, 5, 1. So there's my first transformation over the y equals x to get the inverse. What's the -4 going to do to this graph? Yep, which one? Correct. It is in with the x, so it's going to shift it 4 units, the opposite of what it appears. So 4 units to the right, giving me points there, there, and there. Notice this moves your vertical asymptote. To x equal 4. Questions on any of this? So far, so good? Okay, let's let g of x be equal to 2 minus log base 3 of x. All right. Now, you may want to start with the exponential. You may not have to. I'm going to. Exponential would be f of x is equal to 3 to the x. So I'd have a -1 1/3, a 0 1, and a 1 3. So then my log base 3 of x would give me the points 1/3, -1, 0, and 3, 1. So this would be my, whoops, 4, 5, 6, 7, 8, something like that. Okay. All right, then to look at our transformations, working from the inside out, what's that negative going to do on the log base 3 of x? What's that negative going to do to those 3 points? not over the y-axis, the x-axis. Yep. So what was a -1 is now going to flip to a +1. What was a +1 is now going to flip to a negative. So we're going to reflect over x. And then what's that 2 going to do? Yep. That's going to shift it up 2. So now this guy is going to go up 2, this guy is going to go up 2, and this guy is going to go up 2. Somewhere in there. Okay. Questions? Nothing? Okay. This in the x-axis or okay. So wait, negative. Oh, so all right. So my pencil here is the log base 3 of x, right? Okay. So now this negative is going to reflect it over the x-axis. So what was a 1/3 -1 is now going to be a 1/3 1. And then I need to shift it up 2. What was a 1 0 is still going to stay a 1 0, and then I need to shift it up 2. 3 1 becomes 3 -1, but when I shift it up 2, I'm back to the same point. that that third point kind of threw a wrench in things because we moved off of it and then back to it. Yeah. So, but yes, that's where the negative and then up 2 caused some issues. Okay. All right. This should be enough to get you started on the homework for Wednesday. We haven't quite hit everything in this section. We haven't done any domain work, and I haven't done any of the applications at all. You have enough to complete the applications, but you may not have the confidence level with it. So give them a shot. And if you don't get them, that's okay. I can do some examples of it tomorrow. But you do have enough exposure to the skill content that if you wanted to be able to take a look at it, you could. But we haven't done any of the domain stuff, although again, if you wanted to give that a shot, you could. We've had enough previously that you could try some of the domain information or the domain problems, but I'll go through some of those examples tomorrow too. Okay. Anything else I can help y'all with today? Wednesday is scheduled as a lesson. Thursday is not. Okay, and it's 4.4 for Wednesday. So that's it's applications. 4.4 is the laws of logarithms. So it's manipulations. That's where we'll be doing change of base, Garrett. So Okay. All right. Ben, any last minute questions from you? Austin, you're good for now? Okay. All right. So I'll respect your time, let you go. If you need anything in the meantime, please don't hesitate to ask the questions, okay? All right, guys. Have a good night. We'll see you tomorrow. Bye-bye.